travel beyond the stars and unlock the mysteries of the universe.
Have you ever wondered what truly holds you to the ground? We call it gravity, but this simple word masks one of the deepest mysteries in the universe. Is it a force, as we've been taught since childhood, or is it something far stranger, a concept our minds are only beginning to grasp? What if I told you that our entire understanding of gravity might be fundamentally wrong? For centuries, humanity has stared up at the stars and down at the earth, trying to decipher the invisible tether that connects everything. The story of gravity as we know it often begins with a legendary apple falling on Isaac Newton's head. In the 17th century, Newton gave us a powerful mathematical framework. He described gravity as a universal force, an instantaneous pull that every object exerts on every other object. The more massive the objects, the stronger the pull. The farther apart they are, the weaker it becomes. This was revolutionary. Newton's laws of universal gravitation explained why planets orbit the sun, why moons orbit planets, and why we don't float off into space. For over 200 years, his equations were the undisputed truth. They were so precise that astronomers used them to predict the existence of a new planet, Neptune, just by observing irregularities in the orbit of Uranus. Newton's universe was a grand, predictable clockwork, all governed by this invisible, ever-present force. It was a comfortable, understandable reality. But this comfort was destined to be shattered. As the 19th century gave way to the 20th, cracks began to appear in Newton's perfect model. A tiny, persistent anomaly in the orbit of Mercury couldn't be explained by his laws. It was a small discrepancy, but in science, small discrepancies can be the harbingers of massive revolutions. The stage was set for a new protagonist, a young patent clerk named Albert Einstein. Einstein wasn't trying to fix Newton's gravity. He was wrestling with a different problem entirely: the nature of light and motion. His theory of special relativity in 1905 established that the speed of light is a cosmic speed limit, constant for all observers. This posed a huge problem for Newton's idea of gravity as an instantaneous force. If the sun were to suddenly disappear, according to Newton, Earth would instantly fly off its orbit. But according to Einstein, no information, not even the information about the sun's absence, could travel faster than light. Gravity couldn't be instantaneous. Something was wrong. This contradiction led Einstein on a decade-long intellectual journey, culminating in 1915 with his general theory of relativity. His answer was breathtakingly elegant and profoundly strange. Gravity, Einstein declared, is not a force at all. It is a consequence of the curvature of space-time. Imagine a stretched rubber sheet. If you place a heavy bowling ball in the center, it creates a dip, a curve in the sheet. Now, if you roll a small marble nearby, it won't be pulled by the bowling ball. Instead, it will follow the curve in the sheet created by the ball's mass. This is Einstein's gravity. Massive objects like the sun and Earth don't pull on each other. They warp the very fabric of spacetime around them, and other objects simply follow these curves. Spacetime tells matter how to move, and matter tells spacetime how to curve. With this radical new idea, the anomaly in Mercury's orbit was perfectly explained. Gravity wasn't a pull, It was geometry. It was the shape of the universe itself. Einstein's theory has been confirmed time and time again, from the bending of starlight during a solar eclipse to the recent detection of gravitational waves ripples in spacetime from colliding black holes. General relativity has passed every test we've thrown at it. It is our best description of gravity on the cosmic scale. But here's where the story takes another turn, plunging us back into mystery. Just as Newton's theory broke down, Einstein's theory also has its limits. General relativity works beautifully for stars and galaxies, but it falls apart at two crucial points: the infinitesimally small world of quantum mechanics and the infinitely dense centers of black holes, known as singularities. In the quantum realm, particles behave in bizarre ways, existing in multiple places at once, governed by probability, not certainty. The smooth, geometric landscape of Einstein's spacetime clashes violently with the chaotic, quantized nature of this subatomic world. The two most successful theories in physics, general relativity and quantum mechanics, are fundamentally incompatible. Physics has been stuck at this impasse for nearly a century. We have no quantum theory of gravity. We have no idea how gravity works on the smallest scales. We do not know what happens inside a black hole or what occurred at the very instant of the Big Bang. This is where we leave the solid ground of established science and venture into the esoteric and the speculative. Could gravity be more than just curved space-time? Some ancient philosophies and mystical traditions viewed gravity not as a physical mechanism, but as a metaphysical principle, a universal tendency towards unity, or a form of cosmic love. The Hermetic principle, as above, so below, suggests a correspondence between the macrocosm and the microcosm, hinting at a single, underlying law governing all scales. Could the force that holds galaxies together be a large-scale reflection of the very same principle that governs attraction and bonding at the atomic, or even the conscious, level? Is gravity a manifestation of the universe's inherent drive to connect, to bring disparate parts into a unified whole? Perhaps our scientific language of force and curvature is just one dialect trying to describe a much deeper, more fundamental reality that ancient thinkers tried to describe with words like sympathy, attraction, and oneness. Thinking this way opens up fascinating possibilities. If gravity is a property of consciousness or information, as some fringe theories propose, could that explain its unique weakness compared to other forces, like electromagnetism? The electromagnetic force holding an atom together is trillions upon trillions of times stronger than the gravitational force between its components. Why is gravity so incredibly feeble? Perhaps its purpose is different. It doesn't bind the small things, it structures the large ones. It is the gentle, persistent architect of the cosmos, not the frantic carpenter. Could gravity be an emergent phenomenon, just as temperature emerges from the collective motion of countless atoms? Perhaps gravity isn't fundamental at all. Perhaps it emerges from the complex interplay of quantum information, a holographic projection from a lower dimensional reality. This holographic principle is one of the most provocative ideas in modern physics, suggesting that what we perceive as our three-dimensional universe, including gravity, might be an elaborate illusion encoded on a distant two-dimensional surface. This leads us to the final, open frontier. We are living in a time of profound uncertainty about the true nature of gravity. Physicists are exploring wild ideas. String theory suggests that all fundamental particles are tiny, vibrating strings, and that gravity is just one particular vibration. Loop quantum gravity proposes that space-time itself is quantized, made of discrete, indivisible loops, and that gravity arises from the interactions of these loops. Then there are modified theories of gravity, which suggest that Einstein's theory might need adjustments to explain mysteries like dark matter and dark energy, the invisible substances that seem to dominate our universe. We observe galaxies spinning faster than they should, and the expansion of the universe accelerating. We invoke dark matter and dark energy to explain these observations within Einstein's framework. But what if the framework itself is incomplete? What if gravity simply behaves differently over vast cosmic distances? We don't know. The force we feel every moment of our lives, the one we take for granted, remains an enigma. From a simple pull to a cosmic geometry, to a quantum foam, to a holographic projection, our understanding of gravity is constantly evolving. What will the next revolution reveal? What deeper truth is waiting to be uncovered, hiding in plain sight, holding us all in its mysterious embrace? The apple has fallen, but we are still looking up, wondering why. What do you think gravity is? Is it a force, a curve in space, or something else entirely? Share your thoughts and theories in the comments below. If this journey into the mystery of gravity sparked your curiosity, please give this video a like, share it with others who love to wonder, and subscribe for more explorations into the biggest questions in the universe. Thank you for watching.
Welcome to Deep Space Dreams, where we travel beyond the stars and unlock the mysteries of the universe.